Okay, I hope everyone can see my screen and everyone can hear me. Pop a note in the chat if you can't. So we're here today to talk about spatial separation. Um, the agenda for today is just to go through some of the obviously building code requirements, some of the key terminologies. We're also going to do a small bit of the history requirements behind where this came from. Go into some explanations about sprinklered versus unsprinkled. Go into some of the discussions on exterior wall assemblies, some things we see tripping people up at times, and some things that come up after the fact or get picked up during permit review, or worse again, during inspections on site, and just to try and work around some of those. Also about design optimization, some of the strategies we use as code consultants to try and make your design as efficient as possible. Some of the OBC matrix requirements, and just looking at some alternative solutions and some work we kind of see coming down the pike on what could be, some future code changes potentially, or we could see ways of hopefully making some infill projects a little bit easier that we've been involved in. So obviously, as designers, you're looking at what, you go to design your building, you want to free up and make as much of it open potentially, have as much windows as possible. And then the building code comes along and says, hey, we want you to limit how many windows or how many unprotected openings you have to your adjacent buildings. And often, sometimes people look at the code and go, hey, why is this here? What is it for? And the purpose of the spatial separation requirements is to limit fire spread to adjacent buildings. When we talk about fire spread, it's not no risk to the adjacent building. There is still some risk to the adjacent building. However, it's about limiting that amount of fire or exposure would happen through adjacent buildings, such that ideally you can control the fire when the building is happening. And also just to make sure you're not getting a situation where an entire block is coming down or an entire area of the city. And it's all about also limiting flame hitting the adjacent building and how many openings you can have. So how does this affect you as a designer? There's a few things that happen. One is we mentioned the windows already in terms of amount of unprotected openings. The second one is actually cladding. Once you get close enough to the property line or to your limiting distance, when you meet those requirements, when you say get close, the closer you get, you move into non-combustible cladding. Then you actually, as you get very close to the property line or as your limiting distance gets shorter, you start moving into non-combustible construction, which would, for example, on a stick frame building, could potentially change the exterior wall to now move into being steel construction or a non-combustible material, and it affects how many openings you have. Now, I talk about windows, just to clarify, in Ontario, you can obviously use sprinkler protected glazing as a OBC permitted solution, provided you have no horizontal mullions and you meet all the requirements of the listing. So there are ways of protecting fixed windows in Ontario. That's not all available to you across the country right now, but it is one of the things you can do. Also with this, it also does change how you construct the exterior wall assembly. The closer you get or the shorter your limiting distance, the greater the fire rating you need to have. So it will change how you fire rate it. And depending on how you're actually constructing the wall, whether it's a load bearing or non-load bearing, you could be required to put an exterior membrane on that to try and to work with bracing if you're following an SB2. We will cover off some of these in worked examples later on that Oprite will be taking. So I often like especially on this presentation or this topic, just to explain to people where some of the items in the code actually came from. This is a pretty broad strokes explanation of where they came from. But essentially, in the 1800s and early 1900s, there was quite a number of large fires across North America, where significant parts of cities were burned down. This would predate the National Building Code of Canada and predate a lot of the codes and regulations we would see now. But there was a big push from the insurance industry and and regulators to start actually coming up with a way of trying to limit these large scale fires. So this is an example close to home for all of us, or close that, example we would be quite familiar with. This is the Great Fire in Toronto in 1904. On the left-hand side, you can see what Bay Street looked like. I'm going to say that morning. And then a few days later, when the fire was eventually put out, what it looked like. So you can see a high degree of damage, huge property loss, big displacement of people, and big interruption to a city. This is an example of this is actually the insurance map showing the extent of the fire that happened in Toronto at that time. And for those familiar with the city, you can see it extends just above Wellington West, the whole way down to the Esplanade. And quite a large part of the city was damaged and affected by this fire. So this is primarily what the background was to trying to come up with a way of limiting massive fire damage on this scale. With the spatial separation requirements, you're essentially shrinking this down to be one building and maybe damage the adjacent buildings at worst, but you're trying to limit it so that you're not getting a massive citywide involvement or block-wide involvement. Okay, so how did the numbers that got into the building code come about? An opportunity arrived in 1958 where there was going to be some flooding of the St. Lawrence Seaway project. And as part of that, there was a town, Allsville, Ontario, that was going to be flooded. This allowed for an opportunity to actually burn down some real buildings. One of the things that is quite hard in the fire community is actually finding something you can burn down to test your hypothesis or test your theories. So an opportunity arose, and 6 two-story houses were burned down in 2 large-scale structures prior to the flooding of that. And that's actually where the spatial separation requirements that are now in the OBC originated. This was a joint venture both between the National Research Council of Canada, British, US, and the OFM were also involved. So this is actually where the requirements came from. So I'll just show you. This is them actually part of some of the images from it. You can see there's actually a full documentary on this. I think it's only maybe 20 minutes or 19 minutes, but it actually shows them setting it up, shows them, thankfully it's a very cool actual video to see what they did and how they came up with the spatial separation requirements in terms of the data behind them. And that's still what's in the building code today, whatever, 60 or 70 years, nearly 70 years later. So we talked about just that in 1958. They did the testing. 1960s, it came into the National Building Code, refined over time, and now today we have that in a slightly adjusted format in the OBC. Okay, so I'm just going to talk about just limiting distance. This is one of the key things in the building code. Limiting distance is the distance from the building face to either a property line or to an imaginary line between 2 buildings. This is what actually sets up how much openings we're allowed to have. It's a really key part of any calculation. So when we get a set of drawings, for example, someone comes to us with a project and they say, hey, we want you to look at this. We're absolutely delighted if it's a sprinkled building and it's 9 meters. We don't have any calculations or a very limited review to do. Once you start getting the closer you get to the property line, you have to the more work is required. Also, when you start dealing with unusual shapes, the building code itself is very much thinks like a rectangle or a square. It doesn't really allow for too much variation in terms of how it looks at things. So there is a bit of judgment in how you actually measure some of these. One of the things to be careful with as well is how it defines limiting distance. The distance is actually measured at a 90-degree angle to the building face. It's not, so you take the building face, work 90 degrees out from that, and as you work around the perimeter, it's very easy, as you can see on the straight sides here, that are straightly lined up. When you start getting angles, it gets a bit more complicated in how we have to do these, especially if this is divided up into compartments. If it's not divided into compartments, we'd be taking the shortest distance here, for example. If it is divided up, we could take potentially shorter distances depending on how the building face is orientated. So we mentioned that it's the imaginary line, and that's exactly what it is. When you have a property line or you're facing a property line, that's actually an easy enough situation to deal with because you have a fixed line. You measure from your building face or your compartment face straight to that line. When you have buildings on the same site, This is when it starts to get a little bit more complicated, because you actually get to decide where you put the limiting distance line. You could, for example, assign all the distance to building A, give nothing to building B, and make them do all their exposing building face. So that's where, when you're actually designing multiple buildings on the same site, you start to look at how you want them to interface with each other. For example, if you have retail on the ground floor, you want to get a lot of glazing, maybe into a courtyard area like this, you might be deciding, hey, I'm going to assign X to this and Y to that so that I can get as much unprotected glazing in those areas, or to get the amount of operable doors or operable windows, if you can't use sprinter protected glazing, for example. This is what allows you to do this. There is a balancing act in terms of these. So this is where we would be often playing with numbers in terms of, hey, if I have all these compartments, if I shove this over this way and that way, how can I get this to work a bit better? But that's where you have the opportunity as a designer to decide how you assign these. Obviously, if these are two sprinter buildings and they're 18 meters apart, there's not much to do, assuming that it's, all maybe lighter hazard occupancies, then you'd have an easy enough calculations. Where this gets a little bit more interesting is when you have an existing building and there's nothing really, you don't want to go into the existing building. For example, it might be an existing building on the same site. We deal with this often, for example, in industrial sites where we're adding more buildings onto the same industrial site, or in university kind of scenarios where the university owns all the land, but we're putting a new building adjacent to an existing building, for example, an existing residential building or student residence that wouldn't, for example, in the older code, wouldn't have been sprinklered. So that's when we have to go look at the existing building, figure out exactly what they need to be to have all the openings they have, because they're probably designed around 100% unprotected openings. If they're 100% unprotected openings if they had no building previously adjacent to them. So that's when you'd have to do a bit of work around that, to start looking at what then you're left over with to allow on your new building. And your new building could end up being a little bit more restrictive than you'd ideally want to be, but there's not much we can do if we don't want to go in and do something in the existing building. Tiffany, can you run the poll? Okay. Okay, so Tiffany's running a poll here. The question, just to check in and see how everyone's doing. What is the primary purpose of spatial separation requirements in the building code? Is it to limit the spread of fire from one building to another, to prevent people from seeing into their neighbors' buildings, or to ensure enough daylight reaches adjacent properties? So I'm just going to give everyone 30 seconds to fill that up. We're doing pretty well. I think everyone's getting it right. Okay. Okay, good. Yeah, perfect. So we've nearly 200 people have taken the poll, and we have 99% correct answers, which is to limit spread from one building to another. Okay, so moving on, we're going to talk just about exposing building face and what that is. So the exposing building face is essentially, this is the definition at the top, but it's the actual building face that faces one direction. So I talked about the code thinking like a square or a rectangle, where it assumes that everything's square, it faces one direction. So what you end up getting here is you can do an exposing building face. The code does allow you to do the entire building face as one compartment if you want to. That's not very advantageous. It's much better to divide up the building, or Prete will cover some of that, but it's essentially the building face that faces one direction. It's measured from ground floor to the top of the top compartment, the ceiling of the underside of the ceiling of the topmost compartment. This is an example where, for example, if you're in an office building, you could end up doing it by floor. You can take I mentioned you take the entire building face. You could take a compartment approach, which would be an entire floor, for example, on an open plan office, or if you had multiple offices that are not, there's no rating required between Group D offices, so they wouldn't qualify as different compartments. So that would be one you have to watch out for as well when you do when you divide up the building face but into compartments. The compartment has to be not less than 45 minutes. So you can't do this if you had, for example, a smaller Part 3 building where you may not need a fire rating on the floors in a Group D, in a sprinkler Group D, you would not be able to do this. You'd have to have at least 45 minutes. And this is an example, and this is for nearly every type of building where you are divided up into compartments, this is the optimized approach, which is to take every single compartment and to use every single compartment as the basis for completing a spatial separation calculation. And we'll show why that's important as we move through the slides. Okay. So unprotected openings. What are unprotected openings? Unprotected openings are windows, doorways, anything that's unprotected or unrated. For example, if you have an exterior wall like this, your windows would be unrated. These windows, for example, wouldn't be suitable for sprinkler protected glazing because they have a horizontal mullion. So you would be having to, if you had to meet a spatial separation requirement for these, you would have to either provide fire shutters or provide some other means to achieve the fire rating. So this is what we talk about when we talk about unprotected openings. One of the big changes that happened in the code was to recognize sprinkler reduction. You'll see as we move into the tables, if you sprinkler, you get a lot more unprotected openings that are allowed. Unsprinkler compartments are treated more severely, and rightly so. So with that, you are allowed less openings in an unsprinkler compartment. This is an interesting calculation to do because we've had a few buildings where the buildings themselves are not sprinklered. However, for example, an entranceway or something like that, where we needed to get a lot of unprotected openings, the solution that ended up being cheaper than trying to do fire rating on the exterior glazing was to actually sprinkler the compartment, and that allowed us to get all the openings we wanted to get the doors and get a few other elements that we wanted without having to do additional protective measures. Okay, so these are the tables in the OBC where the spatial separation requirements come from. So what happened is they took the data from the St. Lawrence Burns, they turned it into an equation, and then they turned these equations into worked out examples essentially in the building code. And what it does is it takes our exposing building face, and what it does is it says, hey, that's the size of your radiator, and the smaller the radiator, essentially, the less risky it is, the less amount of heat that can come from that. So we'll allow you to have a smaller required limiting distance. So for example, if we have a building face that is a 20 square meter exposing building face, so for example, a small compartment, at 4 meters, we would be allowed to have 100% unprotected openings. So if you think about that, and we go back to the first one I showed you, where if we had a large exposing building face, for example, of 150, we would need 9 meters to get that. Now, this is for sprinklered group A, B, C, D, and F3. These are all the lower fuel loads in the building code comparative to mercantile and F2 and F1. So these are allowed to have more openings or require less limiting distance. Everything in these occupancies caps out at 9 meters. If you're at 9 meters, you're allowed to have 100% unprotected openings. You'd simply need to note that in your spatial separation part of your OBC matrix, and that this is over 9 meters, so you're 100%. This is an example of, I mentioned about the sprinkler compartment versus unsprinkled. So let's just go to the next slide, and we take the exact same occupancy types. We have 20 square meters. But at 4 meters, you're depending on your length to height ratio or height to length ratio, you're between 49 and 72% allowed unprotected openings. So depending on how it's actually arranged, you can you would be quite significantly, like 50% essentially less. Like you're at this one, you're half the amount that's allowed depending on how it is set up. This is an example for example, we mentioned about 9 meters being allowed here. So once you go over 9 meters, you're allowed to have 100% unprotected openings. in sprinkler buildings, especially when you go, in unsprinkler buildings, especially when you go into large exposing building faces. For example, an F3 unsprinkler building, which you could get at this, this will be very large, but you would get at 2,000 square meters in exposing building face. You need 50 meters over here to get 100% unprotected openings. So quite a lot, quite significant amount of unprotected distance required. So no matter what you're doing in these size of buildings, very rarely do you get to this amount. You're probably working back here in the middle of the table. And even at 9, 10 meters, you're allowed very little unprotected openings. You might need these alone just to take up for doors, a few windows, and any services that are punching through the wall. And this is, for example, this gives the example of the F3 buildings, the higher risk ones where we still at 15 meters, we're allowed 100% unprotected openings. It just addresses the higher fuel load. And they're not quite double, but up very close to it in terms of that 4 meter mark I mentioned earlier. At 20 square, it will be 54 in an F2 or an F1 occupancy or E. And the same thing, we talk about going to that unsprinkler condition. This one actually an unsprinklered, if you had an F2, which is rare enough to have an F2 of this size that would be unsprinklered, but you would require 70 meters to get 100% unprotected openings. There's very, very few sites that have 70 meters exposing building face available for them to use. One of the things that you'll notice in the unsprinkler condition is the length to height ratio or height to length ratio. In part 3, this doesn't actually happen in part 9. Part 9 does not go into this level of detail compared to part 3. But part 9, this one allows you to actually take into consideration the shape of the exposing building face. So depending on if the length to height or height to length is higher, it would allow you to change how you do the calculation. So this is an example of a calculation. You put the length over the height or height over the length, whichever is larger. So it's usually, in this case, it's the length. So you'd be going out with about 2.5. So you'd be fitting into, let's go back to the tables and show you where this works. This is in here. So wherever you fit in, if your length is less than 3 to 1, so that's what we you take the larger one. And you'd be fitting in here into whichever one of these. That allows you to pick which one of these you should be using. And you can see it has quite an effect on the amount of openings you're allowed to have, especially higher up in the table, 22 to 33%, depending on that. So it's something that you have to do as well to accurately calculate out how many openings you're allowed to have. Okay, so that's the background to the calculations. Oprite is going to take you through a few of them in a minute. So we're going to move to that in a few minutes, but let's just talk about what this all means. This you go out, you define your exposing building face, ideally by compartment. You then take your limiting distance measured at 90-degree angle to the property line or the imaginary line, and you actually come up with a number. So you take the number we've got from the previous table, for example. So we've gone to one of these tables and we've got, say, for example, we got 50. And you come back to this table. And this is actually what decides what type of construction you're allowed to have. And this is one of the things that comes up. For example, when we review stick frame, timber buildings, especially on infill, one of the things we're very careful with on the very initial part of the review is to make sure that while the client may want to build it all out of stick frame construction, we may have an issue with spatial separation. For example, if you're very close to the property line, you would be required to have, say, 0. You might be between 0 and 10 permitted unprotected openings. Now, getting 1 hour is fine. We can actually achieve that with drywall. We're not too worried about that. The cladding itself isn't that big of a deal to move it non-combustible, but what can make it difficult is moving the actual timber, the stud, to non-combustible, which would be a requirement if you're very close to the property line. So if you can imagine, if you have a infill stick frame building, a very common material, very flexible to use in an infill, suddenly when you get to the exterior walls, you're having to switch it to metals to steel stud on the exterior, so you're working 2 different materials together, and that's one of the things to watch out for. As you can see here, as you go up through these, the more unprotected openings, the kind of risk level drops off, or how the code looks at it. And it starts to allow you to have, hey, sure, when you're between 10 and 25, you can have combustible or EMTC or non-combustible. We still want the non-combustible cladding. Up to 50%, you're still in the non-combustible cladding, but it does reduce down your requirement on the fire rating. And then 50 and less than 100, you're allowed any combustible, EMTC or non-combustible, and then you're allowed go into, this is what allows us to bring back in the combustible cladding at this stage. So these are very key requirements in the early stages of a project to watch out for, because it could change how you decide or what materials. If you're doing a very narrow building, it may not be that viable to mix the materials together. This just gives you some representation of what it looks like. And I talk about a narrow infill, this is some of the projects we work on are quite narrow and quite difficult in terms of infills. And this, where we sit here in terms of how much we have available, there are times when the calculations are actually very easy. We're within 1.2 meters, you're allowed nothing, no unprotected openings. So we end up having to make sure this meets all the requirements, this wall, to be non-combustible, 1 hour rated, and non-combustible construction. So that's the stud or whatever is holding up the wall. And this works out through as you get further and further away, you're allowed to get to under 100%. You still need 45-minute rating, but over that 9 meters, essentially, you will be allowed to have, or whatever the compartment size requires you to have, no rating at all. Okay, so at this stage, I'm going to hand it over to Oprite. Oprite, if you can share your screen and take over. We will address questions at the end. I see there's a whole bunch of questions dropping in, and we can go through those at the end.
All right, thank you, Jack. And hopefully everyone hears me okay. All right, so the next couple of slides, we will be looking at just going over some examples, looking at some additional exterior wall requirements, some design optimizations, as well as, just concluding on alternative solutions that could also be explored where a deviation is intended. So on the screen, we do have two buildings. So building A, building B. They're both spring-clad buildings, Group D buildings. And when you look at the combined distances between the buildings, we have 18 meters. And so in this scenario, an imaginary line has been drawn at the midpoint. And this essentially gives us a limiting distance of 9 meters for each of these buildings. The result then is that we end up with 100% unprotected opening, as Jack explained earlier. So no ratings will be required for these walls, and we could also have combustible construction as well as combustible cladding on these walls. The next example is very similar to the previous one. The only difference is in this scenario, the imaginary line has been drawn much closer to building B. And so what we then have is 100% unprotected openings for building A, whereas for building E, there's going to be some restrictions because of how close that building is to the property line. So in this case, we have a limiting distance of 0.2 meters, which would then mean that we've then fallen into that 0 to 10% unprotected opening zone. So in this scenario, we have a 1 hour rating for the walls, and the walls would need to be of non-combustible construction and non-combustible cladding. So as Jack mentioned previously, there isn't really any hard rule with regards to the placement of the imaginary line, especially when you have multiple buildings on the same site. You're actually able to sort of move the imaginary line to, where you want, depending on what you're trying to achieve. So maybe in this instance, because of the restrictions that we would have with a limiting distance of 0.2 or less than 1.2, you might be better off moving this at the midpoint where there isn't really any restrictions on the openings that would be permitted for both buildings. But then with that situation, you now end up with a condition where for building A, you would end up with some ratings for the exterior wall. So, but in essence, you can sort of mix and play around with these things to get what you want. So on the screen, we have an open air storage garage. Open air stories is a defined term in the code. It does mean a story in which at least 25% of the total area of the perimeter wall is open to the outdoors, in a manner that would provide cross ventilation to the entire story. For this, we have over 50% of the storage garage open to air. Now, looking at the code requirements, where we have a limiting distance of 3 meters or more, the code does allow us 100% unprotected opening. So that's basically how we're able to have structures like this constructed under the code without any concerns about, how much or how open the building is, especially when you're that close to a property line. Tiffany, could you please run the poll? Thank you. All right, so question we have up on the screen says, a building is required to be of non-combustible construction. The spatial separation analysis permits 100% unprotected openings, allowing combustible construction and cladding. And so the question is, are there additional OBC requirements elsewhere that will govern the use of combustible components in the exterior wall of a non-combustible building? Right, so let's just wait a few seconds for the responses. Okay, so over 88% right now said yes. The correct response is yes. So there are other considerations that we need to put into consideration with regards to having combustibles in an exterior wall. Okay, so outside of spatial separation requirements, there are other considerations for non-combustible buildings or EMTC buildings that typically would regulate the use of combustible construction and combustible cladding. For this presentation, we're going to be focusing just on non-combustible buildings. Now, this is the requirements for non-combustible buildings are governed under 3.1.5 of the Ontario Building Code. Now, when we look at 3.1.5 here, it does address the use of combustible components in a non-combustible building. Now, sentence 1A here tells us that we can have combustible components in the exterior wall in an unsprinkled building that is not more than 3 stories high. And then it also does allow us to have combustible components in a sprinkled building, regardless of the height. Now, when you look at 1B here, you'd see that that's an additional requirement we also need to meet. So the wall assembly with combustible component essentially needs to satisfy the requirement in 31551B, which we've highlighted here. So this is basically telling us that that wall assembly needs to be tested in accordance with CAN-ULC S134, which is an exterior wall assembly test. And when you look at sentence 2 up here, it does say exterior wall assemblies constructed in accordance with section 6 of SB2 is actually deemed compliant with the previous section, which basically says SB2 does have tested S134 assemblies that we can use. So on the screen, we have the prescriptively listed wall assemblies in SB2. So these wall assemblies, as you can see here, has been tested to S134, sorry. And so provided your spatial separation analysis would permit combustible exterior walls, and provided that you meet the requirements we just went through in the previous slide, you're actually able to pick one of these walls for use in your non-combustible building. This is just a tested S134 listed wall assembly by Intertech. Again, this was just to highlight that beyond the prescriptively listed wall assemblies in SB2, there are other tested wall assemblies out there. You just need to ensure that you're looking out for that S134 test for whatever wall assembly you're choosing to go with. We thought it was also very important to bring in the exterior wall construction requirement in SB2. Now, where your spatial separation analysis has been completed, you know that your exterior wall needs to be maybe 45 minutes rated or 1 hour rated. And the intent is to use SB2 in, getting an exterior wall assembly. And we know that SB2 uses the component additive method. Now, this requirement on the screen is very important. It's an additional requirement that also needs to be met if the component additive method in SB2 is followed. So when you look through the highlighted portions, it does basically tell you that on the exterior side of that exterior wall assembly, you do need to have a membrane that consists of plywood, OSB, or gypsum sheeting on the exterior side of the wall, in addition to having the studs completely filled with insulation. Now, this is something we see get missed a lot on projects. And so we need to be, very mindful that if the SB2 approach is being used, this requirement is also being met. There's no waiver exemptions for this. So just something to be aware about. All right, so looking at some design optimizations that could be explored. The first is compartmentation. So on the screen, we have a building that has been divided into two compartments. The first compartment has a width of 8 meters and the second compartment has a width of 12 meters. We'll be looking at two different calculation scenarios. The first scenario would be assuming that the entire building is one large compartment, essentially one large exposing building face. And then the second calculation scenario would be an instance where we take each compartment as its own, assuming that each of these compartments have been separated by fire separation that is at least 45 minutes rated. So for scenario one, which is the combined fire compartment, we have an occupancy or a group F3 occupancy. We've assumed that the building height is 3 meters, or the fire compartment height is 3 meters. The width of the fire compartment we've considered, which is the entire large fire compartment, it has a width of 20 meters and our limiting distance is 4. So for this calculation, in a sprinkler building, our area of exposing building face is going to be 60 meters square, and we are going to end up with an unprotected opening of 50%. So this is where we would fall for this sort of calculation or scenario, essentially having an exterior wall that is 45 minutes rated. And there's really no restrictions on the construction requirement. However, for the cladding, we're restricted to non-combustible cladding. Now, looking over scenario two, the only difference here again is the fire compartment. So we're now taking the individual compartment. So we decided to use the one with that has a width of 12 meters. So again, when you look at the area of exposing building face, we now end up with 36 meters square. So basically a reduction from what the previous calculation was. And similarly, the unprotected openings have now increased. So this is 69%. The other was about 50%. So when you look at, again, where we fall, the fire rating is 45 minutes rating. So basically the same as the other. The construction type as well would be the same. However, we've now moved into the combustible or non-combustible cladding requirement type, which, if that was something that was considered for this project, that's basically a win. And so essentially with compartmentation, you can kind of see how exterior wall requirements change based on the size of the compartment. This is just a summary of what we just talked about. So having one large exposing building face versus multiple compartments, each with a minimum 45-minute rating. Again, you have much bigger exposing building face areas. You could have restrictions with your glazing limits. You might end up with a higher wall rating and some restrictions in your construction wall type. But then it's the sort of complete opposite for when you have the smaller compartments. All right, so moving on to proper orientation and positioning. So I'm gonna try to paint a scenario here. So on this site, we have an existing building. So this is our existing Group C building, and a new building is also being proposed on the same site. So proposed new building beside it. Now, the existing building is a residential building. It's spring-clad. We're going to assume the building is spring-clad, and the exterior walls are not rated, meaning that we also are permitted 100% unprotected openings. Now, when a new building is being proposed on the same site, something you want to put into consideration is basically your existing building, and is it spring-clad? What are the walls rated? All of that scenario. Now, the reason I'm bringing that up is if no upgrades whatsoever is proposed for the existing walls, we need at least 9 meters for this residential building to be able to, get away with no wall ratings and 100% unprotected openings, meaning our imaginary line basically gets pulled closer to your proposed new building. Now, in an instance where the limiting distance for the proposed new building is 1.2 or less than 1.2 meters, then we basically have um, concerns or issues on this wall with with regards to maybe your construction for the wall, for the cladding, as well as having openings that essentially would need to be protected, especially if maybe this is the area where you have an overhead door with access to the parking. So you end up would have to protect all of those openings. So, things that you might want to put into consideration for, putting in or proposing a new building on the same site as an existing building. Now, you can imagine a scenario where this existing building is a mall building that is spring-clad. This gets pushed into the 15-meter limiting distance mark. And so you're even much closer to the existing building. So just considerations to put in mind for this sort of designs. Still on optimization, something else that the code permits is to measure the limiting distance to a point beyond the property line, center line of the street, laneway, or public thoroughfare, provided there is a limiting distance agreement in place. So the building on the left is building A. It's a 6-story building. On the right, we have building B, which is a 3-story building. You'll notice that the property line shown in blue has been jogged over the S space for building B. Essentially, what we're trying to achieve here is for levels 4 and up, we basically have increased the limiting distance for building A, such that for these portions, we actually would be permitted 100% unprotected openings and no ratings for these walls. Whereas for levels 3 and down, because we're still within the 2.36 limiting distance zone, you most likely would have some, ratings for the walls, in addition to a reduced percentage of unprotected openings. But the code does allow us, do this, provided there's a limiting distance agreement in place. So just another way you could optimize some of these things when, there's an existing property on site, you have a new property, and, there's an intent to have no ratings for the upper stories. This is just the OBC matrix, just a sort of a reminder that the spatial separation section of the OBC matrix needs to be filled out when putting in new constructions. And lastly, we will be talking about an area where an alternative solution has been explored in the past. So on previous slides, we discussed cases where we have an exterior wall right on the property line or less than 1.2 meters from the property line. Where combustible exterior wall is proposed, especially, sorry, let's backtrack. So when you have the building right on the property or the limiting distance is less than 1.2, you actually would be required to have 0% unprotected openings, non-combustible cladding, as well as non-combustible exterior walls. And so in that instance, where combustible exterior walls are being proposed, you're basically deviating from the prescriptive requirements of the code, which we've been able to address through an alternative solution. We've had success with this in the past across multiple municipalities. You know, we've been able to work with clients, architects, AHJs to come up with an exterior wall assembly that still meets the intent statements in the code. So that is, you know, possible and something that we've done on a couple of projects. And that concludes our presentation. Any questions?
Yeah, so if you have any questions, you can pop them into the Q&A or you can pop them into the chat. So that's slide 29, Oprite, can you just put that back on the screen? We can have a quick look at it.
Yep. All right.
So question, how does spatial separation apply to canopies attached to an exterior wall? The actual compartment is the exterior wall of the building. So if the compartment if the canopy goes beyond it, assuming it's an open air canopy like a drop off area or something like that, it would not be in the spatial separation calculation. Now there are specific canopy requirements and combustible projections, so just be careful with those. But the building face is the environmental separation. So that's 29, yes. When we were putting this up there, we knew we'd get a few comments on this. If you look at this slide, think of a large built up part of the city where you would say, for example, in the city of Toronto, where you'd walk along, you'd see a condo building, and the condo building has apartments along the side of it that are facing over, for example, an old building beside it, maybe a 2-story or 3-story building. And you might look up and see all these windows going up along the side of the building. What has happened there is typically the new condo developer has purchased the air rights off the person in the building beside them, such that the building beside them cannot go upwards with their building. So that what they would do is they would buy the space above the building. It would be registered on title. I believe the city of Toronto have a standardized template they use, and a number of AHJs have those. Depending on where you are, they may or may not have it, but this is actually a legal issue, not something we write. But they would have that agreement such that you could measure out over the other building and use that to allow you to get more unprotected openings. So that is this comment 29. This is really only seen in very big municipalities. I'd say very dense areas. We don't typically see this in, once we get out of the, where our buildings are a little bit further apart or we don't have very close proximity. We don't necessarily see this. There are examples. There's a question in from Mark. Do we have examples of the alternative solution of 0-meter setback? There's actually a guide that was recently put out. Conrad Speckert and myself wrote, with the Nepsis Foundation, wrote a guide on some of the changes we'd like to see to the building code around various items. It actually has some of the wall assemblies that were approved or similar to those were approved in that. So it's actually a really good guide if anyone wants to go. There's probably a link on my LinkedIn. If not, shoot us an email. We can send you a link and you can see some of the wall assemblies that were used in that. Let me see here. Yeah, that question, I think I just, for Shari Roberts, yes, you are not allowed to build up once in this situation where you have a building A and building B, you are not allowed to take that other building up. So that, as I said, typically those air rights are purchased and an agreement between the two buildings is attained. Yeah, if anyone, I think David, you asked for follow-up. Yeah, absolutely. If anyone has any suggestions for any OBC topics they want us to look at, please feel free to put them into the chat or send us an email, and we're happy to do a presentation on any areas of the building code that would require that might be people might have any interest in. Michael, your part three question, I think we're going to have to take that offline. And same, Naveen, if you want to shoot us an email, we can get back to you on that.
Question
So,
here.
I said, go ahead, Oprite.
Question here from David. How's the exposing building face calculated for a circular building? So in essence, you're considering the diameter of the building because it's all one compartment.
Yeah, the code does think in rectangles and squares. So what if you, for example, there are some round buildings, that we've worked on. How we've approached it in the past, and this is how we've, rightly or wrong, this is how we did it. We essentially, for some of them, they're broken up into compartments, and we take each, I'm going to say, wedge of the circular building. We straighten off the front of it. We take a corner to corner, so we'd be pulling the building face slightly back in, and or sorry, pulling it from the closest point to the property line and squaring it off. We have to square it off to get to do the exposing building face. So there is a little bit of work that has to be done there. It's usually slightly more conservative than the OBC, so it's been accepted. Okay. Any other questions we have, Oprite?
I was just reading a question from team on, can you include the parapets or roof area above the finished ceiling, or must it stop at the ceiling of the top story? So basically floor to ceiling, we don't have to include the parapets.
Just another question there from Anne, about the exterior wall assembly. I suggest you have a look at that, the Nepsis guide we put out that has actually some wall assemblies of how we did it. So it's got some suggestions in there. And I think we've covered most. Is there anyone else in the Q&A? Let me just check. I think all the questions came in the chat. So just on that, I talked about that exterior, that 0 meter lot line condition. What we actually do is we rate the wall from both sides. The OBC rates walls on the exterior from the interior side only, and essentially what the alternative solution is to provide a wall that's rated from both sides. Typically, when we do these, we have to go over and above the OBC to get it approved. So it might end up being a 2-hour wall where you once had either a 1-hour wall. So that's just something to consider. Anytime we do alternative solutions, typically we end up going much beyond the OBC acceptable solution to get it approved. Also, if a number of people have put in questions about interpolation, yes, it's a 4-way moving interpolation. You've got the limiting distance, and you've got the areas, so you need to actually address all of them. So you can find the interpolator online, or secondly, you can use our spatial separation calculator, which we have on our website. Edward, about the two buildings on the same site. It is up to yourself. Typically, we try and make sure we get all the openings we want to not have to rate. For example, if we want to have mechanical coming through the wall, if we want to have doors and windows, trying to balance the two of those out. We may be stuck with an existing building where we have to give it more than we'd like to give it, and then we have to rate the new building. But there's that takes a bit of work to decide, and it's usually I was working with the architects, going, "Hey, what do you want to achieve here?" And coming back to them with something that will work. Okay, we're just coming up to 1 p.m. If there's anything we didn't cover off, please feel free to shoot us an email or get in touch with us. And as I said, anyone who has any topics that they'd like us to cover would be happy to have a look at those as well. Okay, thanks for everyone for attending and look forward to seeing you all in the future with more presentations.